it just looks like this. So it just lists the stations that we're going to process. Max, how do I get rid of this mirror display?
What the ask teacher?
How do I get rid of that thing?
You want to remove that?
Yeah.
Let me see. This indication need to, let's go the configuration. Oh, it's a bug.
Okay. So can you see that up there? Okay, good. So this control file, or these are the sessions that we're going to process. So let me go back to the terminal. And what I want you to do is type the following command. Enter E1 BLINDEP nmf.cnt. And then hit return. E1. E1. So solve assumes that there are different users, and each user has initials. So this computer, I set it up so there are initials for E1, E2, E3. And if you hit return, then it's going to start processing those sessions. And it should take about a minute or two to process the sessions. So is yours working?
Yes.
Let me know when you're done.
You make it first.
I'll make it first. Yep, probably. So what Solve is doing is for each session, it's doing a big least square solution, estimating a lot of parameters. Finished. Good. Okay. So for the newcomers, let me show you what you need to do. So once you're logged onto the system,
Okay.
I'm just waiting for some people to catch up. So were you able to run solve? And did it finish? Okay.
I need to download the video.
No. It's a different subject this afternoon. So you guys are logged in, are you back there?
The
Okay. So once you're logged in, type CSH. And CSH sets a Unix shell. It sets some series of commands. So that's the first thing you do. And then you're going to type source
So can you zoom in, please?
Você escreve o source, aí você bota slash, você vai completando com o tab.
How do I change this font? Can I make this bigger here?
Right button in terminal, teacher.
Right button.
1 second. Deixa eu ligar. Let's go. Your computer in another configuration.
Okay.
Preference. Okay, let's see. Name it to general. Size.
No,
Let's try.
that's okay. I don't think that's going to work, but
Color text. It's the text. Cell. No, not that. It's that. Close. Let's check. No, the
Okay.
file. Let's change the.
so sorry that I don't know how to do it, but
Let's try.
have you typed in source/SGP? You've got that? Okay. And as a way to check that everything is okay, type in ls dollars mk5 root. And that should give you a directory listing of just some area. You see something like that?
I found it. I found it. It is option.
Okay.
Right button.
colocar em tela cheia, não?
That's not changing the size though. It's just
Ah, no, no. It's
No.
not that. Sorry, teacher. Sorry, teacher.
let me go back to what it was.
Será que me dá no projetor, não?
Não,
Ok.
isso aí é a coisa da fonte. Não vai mudar, não.
Okay. Now what you want to do is CD to your home directory. Just
But it was dollar what?
it was LS space $sign MK5 root.
Ah. Now I found it.
Now you found it.
Full size. You need to put a full size and view zoom in. Better.
Ah,
Okay. So go to your directory, change directory examples, solve. And let me know when everybody is there.
O que você vai tratar? Você vai mostrar. Já mostra as notícias que aí o próximo que a gente quer abrir é qual? É o solto, né? Qual é? É o. Não se declara. Ah, é sets. Sets. Ok.
So are you guys there, Eric?
Enter. Próximo código é. Agora sim, pronto. Capaz. Underline list.
Okay. Type the following. Enter space E1 space BL independent NMF.CNT.
Okay, enter.
And when you're done, hit return. And this is going to start solve processing a bunch of sessions.
Ok,
não, apareceu. I don't know if I typed something wrong.
It should be let's see, CSH. Let's get out here.
conseguiu aí para somar então?
I see. You misspelled that. Okay. Okay, so now type in this command there.
Usa o dado e completa a sentença.
So when you've done that and it's completed, let me know. So yours is completed. Yours is completed. Yours is completed. Okay.
Same problem that
Uh-huh.
so so
Come here. Let me see what problem you had. Oh, okay. It's just misspelled.
okay.
Okay. So Eric, is it running? Are you done? Now we're going to do something similar, except for this time, we're going to say enter E2
That's a problem. It's for the computer is processing out the wireless. But it doesn't let me type.
The computer doesn't let you type.
Yeah.
So type that command, and what we are doing is we are going to look at the effects of two different mapping functions. One is a Neo mapping function, and one is a Vienna mapping function, Vienna mapping function 1. And the purpose of this exercise is to see which mapping function is better. So, we just did the stuff for the NMF. Now we're going to do the stuff for the VMF1. So, enter that command in, and then it will take a minute or so to go through all of the results. And let me know when it's done.
So I didn't understand. We need to do the same thing, but with the V and F1.
Yes, instead of typing E1, type E2. You already did that. Okay. Okay, so guys all done? Now, I'm just going to look at the some of these results. And there's this Unix command called more, which just lists files. So I type more $spoolder / SPLF E1. So that's the first solution that we did. And you should see something like this. So at the top of it, it tells you what the control file was, and then it gives you information. And if we hit space, It just goes through and tells you information about this solution. And so at one point, it's giving you information about the estimated positions.
It was dollar, spool, and what else?
Dollars, spool underscore file. There. Dollar spool dir. Okay, do you guys see it? So, this tells you this, what you're looking at here is the output of this solve. Solve stores output in an ASCII file called a spool file. And this has, we just analyzed 15 sessions, and for each session, it has information about it. And if you go down far enough, you'll start to see things where it's estimating the station positions. And it has clocks and atmospheres and lots of stuff like this. So this has like a ton of information in it. And you can do stuff by hand with this, but usually what you do is you extract this information and then you do something else with it. So that's what we're going to do next, is extract information from these two runs that we did. We did one run E1 with NMF and another run E2 with VMF. So to get out of more, you just type quit. And the command that extracts information is called getPar. So I'm going to type getPar $spooldir SPLFE1. So I'm saying to open up this particular spool file, which is named SPLFE1, and then I'm going to dump the results in the directory temp. And it's going to be temp/NMF. And let me know when you're done with that. So do you see something like this?
Aí podia ter essa.
And then you do the same thing for VMF, but you say E2, SPLF E2, space /temp /VMF1. Done. Okay. So let's look at /temp vmf1.bas. And I'm going to look at it using more because it's just easy. And if I look at this file, it has a bunch of lines like this. And what this is it tells me the session it came from, it tells me the time it came from, and then this is a particular baseline, Badari to Fortaleza, and this is the baseline length, the length between the two. This is the uncertainty, and then here are other components of the baseline. And it does this for all of the baselines and all of these sessions that we processed. So this is extracted information from the spool file, but it's still a lot of information. Now, what I'm interested in is what is the scatter? What is the variation of this, say, Badari to Fortaleza baseline? And to do that, there's another command, and you type in BAS REPX /temp /NMF .base /temp NMF .sum. I will wait. And what this is going to do is read in and calculate some statistics.
The right comments was wrong.
You should have a space there. And it should be
Is that? Thank you.
okay. So have you typed this in? I'm going to give Max a chance to catch up.
Yes.
Okay, got that? Eric, are you guys ready for me to?
Delta não é nada. Oh, meu Deus do céu. Não, meu Deus do céu. Delta não.
Max, have you done it?
Error termination black trace. So I need to. Já deve que eu vou em outros
Nothing bad happened
em Linux.
in Linux. Okay.
Okay. I can see that.
So, Eric and company, are you guys done? How about you? What part are you on?
Once find the file. Let's do again.
Okay.
This in your computer, and when we type this file.
Word it.
Okay. There's an intermediate step you need to do. You need to do
Got it.
Would never say.
okay. So that's then. Oh. Okay. Now do the same thing with. Change that to E2 and that to VMF1. Okay.
Yeah. Enter. Deixa eu ver. Agora eu vou tá? Viagem sempre. Não, isso. Agora o código certificado não. Deu certo.
So, has everybody made this nmf.sum file? You have? You have? You have? Let's take a look at that. So I'm going to look at it by using more/temp/nmf.sum. And this is just summary statistics of this. So reading this is a baseline. It tells me how many sessions it is, what the average length was, what the scatter was about that. So this baseline was in 15 sessions, and the RMS scatter was 14 millimeters. And this gives other components over here, but we're just going to focus on the first one. Pardon? Weighted root mean square. Means square. So it's the standard deviation. So it's the variation in that particular baseline. So this is for NMF. I'm going to do the same thing, or we did the solution, the solved solution for VMF1. And let me see if and then we can do get par to extract that. Get par to there's and that should be in solution E2 / temp VMF1. And then we're going to, calculate this baseline repeatability using this baseline rep program. So now I have two files where I have this baseline repeatability calculated. And the next thing I'm going to do is plot up the results to take a look at them. So let's change directory to Python. So go up a level to, it's under examples Python. Okay. And we're going to start Python. Who here knows Python? Anybody? Good. Then you can do all the programming for us. I'm going to open up the interactive sort of development thing, idle 3.9. And this should open up this shell like that. Do you guys see it? Do you have it? We're going to open up a file, say open, go to this file thing, say open, and then we're going to open up this Python script. Very simple Python script. And I think that in yours, there's a typo in the top line. And I mean, this is what it should look like. Import pandas as PD. I think there's a typo in import. Do you have it open?
My computer
It's dead. Sorry. Problem solved. Okay, so once that is removed, type run. And what that's going to do is it's going to sort of load these things into memory. Yeah.
That's another sentence in terminal.
I'm sorry?
Another code in terminal. Cats, read.
Cat means just type it.
Okay. Cat, read me to.
So that's just a reminder to me. So now that we have this run there, we're going to type run. And it's reading in various stuff in Python and getting things ready. So if you look in the Python file, there are several programs here. There's one program that's going to read in these baseline summary files that we just generated. And then there's another program that's going to plot these things up. So I'm going to read in the data into the baseline from the baseline summary files. I'll type in NMF equals so I just give the path to the file name. And if I type NMF, it should give me some information about it. So I've read it in. I'm now going to do the same thing with, so you guys back there, is it working for you? I'll give you a chance to catch up. It says quotes / temp TMP / NMF dot sum end quotes.
I need the last comments.
Pardon?
Catch.
So just three. Uh-huh. Ampersand. So have you got that? Max. Now you need to open up this file here. Go type file and then read baseline sum file. Come here.
Esse vai dizer. Ah, ok. É o que deve.
Okay. Okay. So now type in.
Ah, ok.
Okay, guys, have you typed it in? Are you guys back there all caught up? So guys back there, are you done it? Do the same thing, but for VMF1. So type VMF1 equals blah, blah, blah / temp VMF1.
VMF1, right?
Yes.
Ok, got it. Yes.
So now we have this two sets of data into memory. And I am going to plot them up. So I'm going to do plot pair PAR NMF VMF1 quotes NMF quotes VMF1. So all those quotes do is they're telling me what to call these things. So there I plotted up. So you should get something like that. And what this is, it's a plot of the baseline scatter versus baseline length. So do you guys have that up?
It's not a dot, right?
What?
It's a comma. It's a comma.
Comma.
Let's try. Let's try. Raise back. Ah, I make 6 blocks and they like that. Okay. ensino médio.
So let me know, do you guys see this plot?
Yes.
Yes. So tell me about this. What do I notice about this plot?
Eu esqueci a.
So what happens as they go to longer lakes? You've got different orders?
It's all red. There's no blue.
You've got different colors?
And just red dots.
Interesting. Okay, I know what happened. NMF, so that's NMF. VMF. That should be VMF1. You put in NMF.
So if I just change here and
You can't do that.
okay.
That doesn't work that way.
I need to do all over again.
So no, you can go down here to, let's get down to where we were. Okay, so let's close this thing. Where's the plot?
Here.
Trying to find a picture of the plot. Okay. So now type in VMF1 equals read baseline sum file.
What?
So type in type in quotes first.
What's codes? I don't know. Here.
Okay, slash temp slash VMF1 dot sum.
Close the.
Close the quote. Yeah. Close the quotes
Yeah,
too.
yes.
Okay, return. Now typing that in.
This what?
Yeah.
But it's not defined. Dot pair, NMF.
Yeah.
Now type it. Now try it.
Thank you.
Okay. Got it? So Eric, does it work for you guys back there yet?
Just two red dots.
Make sure that you've read each of them into the different ones. In fact, maybe you, okay. I mean, let's work on this in a little bit, but, so are you both, what's your name? No, the woman. Yes. Caroline. That's my wife's name. So easy for me to remember. Caroline, uh, does it work for you or not? Are you, she's not doing it. She's just your friend.
She makes it a lot of that, so she didn't look.
Okay. Um, I'm going to, I want to make sure that everybody's on the same, on the same page, but I'm going to go ahead and just do the next thing I was going to show you. And then we'll go back and make sure that everybody can do this, because we're going to use this as a test. So here I plotted up these two things here, the VMF1 and the NMF. And if I look at this, one of the things I notice is that generally, as I have longer length, my scatter increases, right? The other thing is, if I look at my results here, sometimes NMF is lower, sometimes VMF is lower. And one way of determining whether something is better is, does it decrease scatter? So the next thing what we're going to do is, I'm going to plot up the difference between the VMF and the NMF. So I'm going to get out of here. And I'm going to type plot diff NMF VMF1 NMF VMF1 and I get this plot. So the interpretation of this is that here is some particular baseline, which is at 10,000 kilometers. And this is the difference in the scatter between the NMF and the VMF. So if most of these points here are above 0. So what that tells me is that most of the time NMF is worse because the scatter is worse. So this is for one data set, but there are other data sets that we could look at. And, there are other data sets we could look at. And if this remains true for other data sets, then the conclusion is that NMF is a better mapping function. So let me summarize the steps that we did to do this. One is we ran 2 solutions, one solution with NMF as a mapping function, another solution with VMF1 as a mapping function. Then we extracted the data using getPar, and then we extracted the repeatability using base_repex. And then we just use these Python programs to look at the stuff. Yes.
What's the graphical WRMS?
This is the RMS. This is the scatter, weighted RMS. So that means the RMS is weight, when you're doing the calculations, you weight by the uncertainty. So, what time is it? It's 3:10. What I want to do is I want to make sure that everybody can do this. And then I want people to do the same thing where they compare VMF3 with VMF1. And this is how we test models. Is we look at this, we run lots of tests like this. This is, to my mind, pretty clear that VMF is better because the vast majority of the points are above the axis, and a lot of them are way above the axis. There's some points which are not, but nothing is perfect. So, were you able to get this far? No. Okay. This one?
Yes. The same this file. The row of, yes. BMFU equal read baselines. The continuous of this.
There's another one that says NMF equals. So it could be that when you were made this NMF sum file that you used the wrong, you made it incorrectly. And can't be. Let's do it from scratch now that we know what we're doing, okay? It is, so keep the Python stuff there because we've already read it in and everything's set up. But we're going to make the other files from the beginning. So let me get rid of this thing here. So go to this window here, okay? First off, let's make sure that the spool files that we're looking at were made correctly. So we're going to type more slash, or not slash, but dollars, spooldir SPLF E1. And so mine, if I look at it, it says E1 baseline independent NMF. Do you see that up there?
Yes.
Okay. In fact, since I'm just interested in the top of it, I can just type. It should say SPLF E1 and then SPLF E2. So I have SPLF E1 is baseline independent NMF.cont. Okay. Now, instead of doing more, do head. So now do head and do SPLF E2.
Okay.
And what do you see there? Okay, so does that say NMF? I mean, does that say VMF?
Yes. Where's the NMF?
It's right there.
No. BMF one. Okay.
So that says VMF1. The other one should say NMF. So this one says NMF. This says VMF1. Okay. The next steps are type get par slash spooldir SPLF E1 spooldir SPLF E1 space slash temp slash NMF. So what that's saying is read the spool file and then put all the stuff in under temp. Okay. Now we do the same thing with VMF1, but this time we're doing SPLF E2. Okay. Got it? Eric, what's the problem? Hey, Cindy, I'm teaching class. Okay. So here are the commands that I've typed so far. Okay. Are you there? So we've extracted the stuff for the NMF solution. Now we're extracting the stuff for the VMF1 solution. Now we're going to make this summary file. And that is base repx baseline repeatability slash temp slash nmf dot bas slash temp slash nmf dot sum.
Nossa. Okay, next time. Okay.
Okay. Got it? Okay. Now we're going to do the same thing with vmf1.sum.
Teacher, have we choose some?
Okay. Should be vmf1.base slash temp
Okay, got it.
Okay. So you guys back there? So I'm just checking to make sure they did everything correctly. So I typed in head / temp / nmf.sum, and it tells me where the information came from, and then gives me some information at the top. And if I do vmf.sum, it should look similar but different. So do you guys do that? If I look at the top of the two files, they're similar, but their difference is over here. Okay, so now everything should be set up. Let's go back to our Python screen. And read in both of the files. So it's nmf equals read baseline sum file Let me know when you guys are ready. Are you at this stage?
Check. I can read the terminal, but if I put the command in terminal in Python,
You didn't do a slash before the temp.
okay.
Okay. Are you ready to try to plot the pair?
Right. What is the let's plot now?
Não é.
I'll take a look in a second. Perfect. You got it? Okay. So once I have, right after this, well, I'll talk. Once you have this plot here, you can save it to, your file if you want to, and use it for texts or things like that. So I find Python is a good program to play around with data and to plot things up. So after the break, we're going to look at VMF2 versus VMF1 using the same data set. But I want to make sure that everybody is, on the same page. So, leave your computers as you are. Don't log off. That way we'll be at a head start. So Eric, let me take a look at your stuff. And a break time, and we'll come back in 20 minutes.
I tried to do everything from scratch, but probably I forget something. I do this and don't.
Okay, let's do
O Python é mais fácil de tu colocar as coisas em graça.
Sure.
Só pra...
Você vê que é mais fácil no Python de transformar o valor. A parte que falta aqui no token.
Okay, so previously we compared the results of using these two different mapping functions, NMF and VMF1. And VMF1 is a mapping function developed by Technical University of Vienna, and it uses ray tracing through numerical weather models, whereas NMF just used radiosonde data, and it's sort of the average over the year, and it doesn't change, whereas VMF1 changes every day. You have a new mapping function every 6 hours. So it should be a better indication.
It uses ray tracing like in the games or something completely different.
So when I say ray tracing, what it does is that it has a source out here, and it ray traces through the atmosphere. And based on the index of refraction, the path of the ray changes.
That's because we use ray tracing games for shadows.
Yeah. So it's slightly different, but yeah. So that's what VMF1 does, is it uses ray tracing.
Calculate the ray of light, right?
To calculate the delay.
Delay.
And VMF3 is a newer version of it that came out, I don't know, 5 or 6 years ago or something like that. And what we want to do now is compare VMF3 with VMF1. We saw that there was a pretty big difference between VMF1 and NEO mapping function. So change directory.
So VMF3 will become the standard.
VMF3 is the standard. Yes. VMF3 is recommendation for people to use. Yes. So recently I had somebody from the SLR people still use VMF1. They don't use VMF3. And so a few months ago, somebody asked me, why did VLBI switch? And I showed him some plots, and he said, that's pretty clear. So let's go to the directory. We're in Python. Let's go to the directory solve examples. So change directory ... /solve. And if I do a listing there, I'll see all of these control files and stuff. So what I'm going to do now is we're going to run another solve solution using VMF. And we're going to use we're going to say E3 this time, so that we don't overwrite what we did before. I do blindp vmf3.cnt.
teacher, what's the last name of the file? VMF3?
Yeah, vmf3.cnt.
Okay. V dot CNT, right?
Mm-hmm.
Okay. Do it.
It's loading the warnings.
It's going through it. It's running it.
Tá só, por isso não. Porque tava aparecendo tudo.
Now, on the computers that we use at Goddard, or that I have on my desk, I can process all 7,000 sessions in a few hours. It used to be that it would take like a week to do it, but things have gotten much faster. So let me know when when it's done.
Loading. Finish.
Done. Okay. So now we're going to get the information out. We type get par dollars spoolder slash SPLFE3 slash is space
Finish.
temp VMF3. So all we're saying is, extract this information, then put it in the temporary directory. Okay?
Oh, understand. After the spell FE3, the space, the directory I select to
Yeah.
directory for right?
Yeah. Mhm.
Understand.
So then it gives you this message saying it's written all of these files there.
Yes.
And so let's now, we have this information about the baselines. We're going to extract this baseline repeatability. So let's do a
Names in the line.
base rep base underscore repx slash temp slash vmf3.bas space slash temp slash vmf3.sum.
No, I can see it.
So do you see that? Have you done that?
Yes.
Got it. Okay. Now, just to check on this, I'm going to type slash head slash temp slash vmf3.sum. And what that's going to do is it's going to print the first, I don't know, several lines at the top of the file. You should get something like that. And if I do the same thing for vmf1.sum, I look at the top line here, this says the RMS over all baselines is 6.27 for VMF1 or for VMF3. For VMF1, it's 6.3. So there's a slight reduction. Now go to the window where you have the Python IDE. Where is that? It's here. And we're going to read in that file that we just created. So type VMF3 equals read baseline sum file
Not showing the when I enter Python.
You need to close the window.
Need to put some. It's not showing this.
you need to get rid of, you need to close that.
Okay.
If you have your graphics window open, you need to close it. Okay.
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 Base. And then equal.
Let me know when everybody's caught up here. Max, have you read it in yet?
Let's try I found the copy.
I think we'll do it on. Well, that's well. Saiu de novo lá do.
So the question is, the comparison between the different mapping functions was made with data from a single day. No, it was made with 15 days of data. 15 days. And so that's one question. So the other thing is, can we expect similar results if we use a whole year? And the answer is yes and no. And the reason is because over a year, you have large seasonal variations that might make the results more difficult to see.
Excuse me, sir. The connection. Yes. Okay.
So going back to that, this guy was asking if I use a whole full year of data, would it look better? And the answer is I'm not 100% sure. I think that the effect might not be as marked because over here you have other effects that tend to mask it. So what we like to use is we like to use a small data set that is short in time. So here I used data from 2014, where we observed the same network for 15 days. But I have other data sets like from 2005 and 2017, and I can do exactly the same analysis with that, and I'll see exactly the same sort of thing. So now I've read in this VMF3 information in here, and we're going to do the same thing that we did before, and then I'm going to plot up both of them. VMF1, VMF3.
Agora,
And this time, if I do it, the differences between the two are much, much smaller. You got it? So you see two sets of things, right? Okay. They have the same problem that you were?
Like the view have one of the not show them. Like that. If you got it,
You got it?
that work.
You got it. Okay. So now let's plot the difference.
Why is that different?
okay.
So here you can see that the results are more ambiguous. It looks like about as many points are above the line as below the line. If I look at other data sets, VMF3 is superior, but on this one, it's hard to tell.
Material graphic, it seemed that VMF3 was consistently closer to the middle line than the VMF1. Every plot of the VMF3 was below VMF1.
Well, that can't be true because here I'm just taking the difference between the two. So there's some points where VMF1 was closer.
You see, in that graphic, if you imagine the line, and the data points for VMF3 and VMF1, you can observe that VMF1 and VMF2 was closer to that imaginary line. And if either above or below, have you observed that?
I'm not sure I understand the question.
The previous, just
The one we just did.
But
This one.
most of the imagine a line, just a line, just those points, a regression line.
Uh-huh.
And you see that when they form clusters, little clusters, you can see that VMF3 is closer to that imaginary line than the VMF1.
Maybe. I don't see it. Maybe.
They are very pairs, VMF1 and VMF3.
Okay.
Very closer than VMF1. I see that.
If you want, you can compare it with the mails.
I see kind of a line of adjustment, and we can observe that every blue point the point seems to adjust better, and at least it seems to be closer than VMF3. over
Maybe.
VMF1.
I see what you're saying. Yeah, more outliers.
Yes.
Yeah, I'm not sure exactly what's causing that.
Sometime.
You can. I'd have to change the code to do it.
Okay.
I mean, I just wrote this code in a half an hour just to plot something up. Let's see. Yes.
Another question. Comparing the different plots and baseline plots,
Uh-huh.
these plots don't see another plot. Why?
So what these are here what I'm doing is I'm taking the difference between those 2 points and plotting it here. So for every pair of points here, I just plot the difference.
Oh, it's in VMF1 and VMF3. It's so close, so indifferent, so unclaimed.
Yeah, yeah.
That's-
Yes.
Oh, okay.
Okay.
Thanks.
Okay. So now that we've done this, let's do one more example of testing a model, and then we're going to go, and then I'm going to call it quits for today, I think. So let's go back to the solved directory. You're right there. And we're going to do copy baseline independent vmf3 to just test.cnt.
Yeah. Yeah. Test. Test. Loss. Okay, got it.
Got it? Okay. So let's type in see if that works. Okay. We're going to modify this file.
Okay.
And go down to a place where we have mapping.
I found this.
You see that area where, let me know if you finally got,
Teacher.
yes.
I lost the last line of code. Last one after the test.
Just say edit space test.cnt.
Okay. I got
Okay,
it.
I can go down low.
Yeah, go down low. It's almost at the end of the file. And see if you find this line that says HFEOP. Oh, wait. I think edit is the wrong command. Let's try something else. Cancel. Type gedit test.cmt. I think that's better. Yes. So I changed it to say gedit space test.cnt.
How do I get out here? Because if I close, we will close the terminal and I will lost.
Type Q. Sorry, you broke it.
All three of us is the same. Are in the same.
All three of you are in the same boot. Okay. Type. Let's see. How do I do that? Type escape.
So what we was?
Do escape.
Okay.
And then shift. Bring their computers and I'll fix it.
Okay.
They got it?
Close the terminal.
Okay. So let me know when you open up this file, test.cnt using gedit. Uh-huh.
Therefore, the dollar I unity 5.
You need to do
I remember that.
okay, everything's set.
Thank you.
Okay. So edit the file, open up the file, test gedit test.cnt, and go to line 409. Now, you may have that line highlighted. And to turn off the highlighting, there's this window over here, and turn off highlight current line. What we want to do is, in the beginning of that line, put in a star. And what that does is says ignore this line. It becomes a comment line. So what we're doing is turning off a model. Have you got it done? And then save the file. And then you should be able to
Isn't showing to you, but there's next.
there it is. Okay. Okay, got that all done. Okay. We're going to run a new solution on this file, but this time I'm going to say enter SB test.cnt. So this is exactly the same solution we did beforehand with VMF3, but the only difference is we've turned off a model for sub-daily EOP variation.
What's the place? The date? What's the place?
This one there. We want to put let's turn off the, okay. So there, put a star there, and then save it.
Ah, okay, thanks.
So have you guys run a solution? Let's give Max a chance to run the solution.
The ignition. Myself and turn off the hotspots.
So, Max, type enter space SB
Space.
SB space test.cnt. Okay. SB. Yeah, as in bulletin. Did it work?
I just SB. Enter. Okay.
Okay. Okay, so let's now get the data ready. So the first step we do is we say get par slash spoolder slash SPLF SB. Those are the initials we used. Then you're going to say temp slash test. Is yours done yet, Max? Loading, still loading. Okay. Did it work? Yours is done? Okay.
Okay, I got it.
So now we've done that. We've dumped this stuff up. We're going to now calculate the baseline repeatability.
Base. Test. Got it.
Let me know when you've got it back there.
Now put that screen right there.
Done? You've done the space rep stuff? Yes. Okay. How about you, Max? You're done. Okay. Let's go back to Python. And we're going to read in this file. So we'll call it test equals read baseline sum file And then I'm going to plot up the pair.
Ah,
Let me know if you get a plot like that.
yes, I made with BMF one points.
Okay. Okay. So is it working for you guys back there?
I say the I don't know the name. He's wrong.
You don't have a comma between them. See any of that comma there? Okay. So this plots up this pair of results here. If you look at it, which points are higher on here? Test is higher, right? So it's pretty obvious from here. Let's plot the difference plot up. So close this one out. And then we're going to do And when you do this, you can see that there's a big difference in whether you have this high frequency model turned on or off, which means that pretty clearly this model is improving the data. Now, back in the 1990s, people started to worry about sub-daily variation in the rotation of the Earth. And this rotation of the Earth is caused by the tides. The tides, wash against the shore, and they cause the Earth to rotate back and forth with frequencies that are on the order of 12 hours and on the order of 24 hours. The effects are small, but there's variations in UT1 and in polar motion because of this. And so a bunch of different people wrote papers about this. I was one of the people who wrote a paper about this. So then they made a model, and they made a model which became part of the IRS standards in 1996 for the first time. And there were problems with this model, and I complained about it at different times, and so they put in changes to the model. And back about 4 or 5 years ago, I was appointed chair of a working group to try to find out what the best model was, or a better model. And now we have a better model, which is now part of the IRS standards. So there are lots of things you can test in here. You can turn off pressure loading to see what kind of effect that has. You can do things with, we have models of gravitational deformation of antennas. So you can turn that on and off to see the effects. Maybe we'll do some of that tomorrow. But this is the sort of things you can do with Solve. These solutions were all independent, which means that each session was treated independently. But you can also do solutions where you stack the data together. And that's something else that we'll do tomorrow. If you want to find out what the velocity is of a station, you need to stack the data over different time periods to extract the velocity. So, is it clear what we did this afternoon? Yes. So we did different solutions. We looked at baseline repeatability as one of the measures of goodness. Let's get out of here, but another measure of goodness is the fit. And we do head /temp/test.rms. And what that does is that's listing just how well each of the sessions fit. So the first session had an overall fit of 30 picoseconds, and is 29, etc. So this is with this test model. But let's look at what VMF1 looks like. And if I look at VMF1, the numbers are all much smaller. I have 30 versus 28. I have 29 versus 27. So this tells me that within an individual session, having this model turned on improves the consistency of the data within this session. So I have like two kinds of tests here. One is I look at an individual session, does it improve things? And then I can look at several sessions to see if the consistency is better across sessions. Okay, so that's it for me for tonight. And is there anybody online who has any questions? Okay. And if you guys have anything special that you're interested in, think about it overnight, and then maybe tomorrow we'll do some stuff. Remember, pizza party on Friday. We're going to have pizza party and then break. And then after the pizza party, it's going to be done. And I get to go home where it's snowing. So Christmas. Real Christmas. Not like you guys have here. Santa Claus? Sunny. Okay, well, that's it. So I gotta log off and
The pizza party will be my birthday.
will it be your birthday? So how old will you be? Okay. I used to be 19 once.
And in July, right?
Yes.